Hello and a very good day to Dr. No RZZ. My name is Punjun Phai with the matrix number AE190091 from Group 7 of Section 2. In this part of the video, I shall be presenting the introduction part. So without further ado, now I shall begin with the introduction. So a control system is defined as a system that uses the control loop to command, govern, and regulate the behavior of a device or system. For example, a residential boiler to big industrial control systems that are used to control processes or machinery often uses thermostat control. A closed-loop control system or feedback controller is used to automatically control a process or operation for constantly modulated control. The control system uses the difference as a control signal to bring the process variable output of the plant to the same value as the set point by comparing the value or status of the process variable being controlled with the desired value or set point. Controllers are commonly used in this project. Usually, its performance is determined by the set point value. PID controllers, as well as customized versions of PID controllers, are widely employed in today's businesses and laboratories and other manufacturing plants due to their user-friendliness, solid reputation, and simplicity of usage. The control design problem for linear and stable systems is relatively straightforward in comparison to unstable and non-linear systems.
Very good morning to all the lecturers who is watching this video presentation today. My name is Lee Jin Jo, and now I'm going to present with you about the literature review parts of our control system project. So this part is start with a presentation of task examination themes, through our conversation of central hypothesis of PID regulator. The entryway opening control framework is made utilizing MATLAB program in this starts, and the PDI regulator is the fundamental segment and the framework that goes about as a regulator. And before we have start to fabricate the framework, we should initially comprehend the hypothesis and idea of the PID regulator. And comparing fundamental auxiliary controller is which is known as a PID controller or three-term controller, maybe a criticism-based control circuit instrument broadly utilized in cutting-edge control system and distinctive application that required presentively balanced control. And a PID controller computes a bumble regard as the differentiate between a perfect set point or regard and a consider interaction variable reliability and applies relative, vital, and backup crews. And the principle of PID regulator study paper we went over was an improved PID regulator plan strategy utilizing an inner criticism PD regulator, an upgraded PID regulator for speed control of brushless DC engine depends on rise set enhancement. And the recommended regulator structure is comprised of a rise assortment of PID and PI regulator with an inward PD regulator. And the subsequent investigation since how to manage a program site entryway utilizing a PID streamlining control technique depends on gravitational pursuit. And next is about the examination papers talk about the utilization of PID in servo motor control. Is an examination with the title Technique of PID Control, a contextual investigation for servo motor and the exploration utilize an assortment of tuning draw nears including the supposition and check technique and the Ziegler-Nickler strategy to tune the control framework. And experimentation can be utilized to decide the addition of a PID regulator. And in the methodology, the controller I and D terms are set to 0 first, and afterwards the relative additional is expanded until the circle yet level. The framework turns out to be quicker when the corresponding addition is expanded. And to get a little consistent state mistake, the vital terms is iterated. The subsidiary terms is expanded until the circle rushed to its set point after the P and I have been set to get the necessary control framework with low consistent state bladder. And besides that, the following examination paper is tied in with utilizing PID control on a hatchery and the paper name Savvy Hatchery dependent on PID regulator, contain an explanation that zero in on controlling the hatchery's temperature and mugness to accomplish the fundamental condition for sure hatchery. And a PDI regulator is utilized across the explosion to control application that emits through temperature, stream, pressing factor, speed, and other circles factor. And an exploration then at the point contrasts the Simulink demonstrating circuit and the variable association while using a PID regulator to control the speed of a DC engine. The yet execution pursuit the standardized word in PID is amazing near exactness toward the finish of their examination. And other research we have done remembers the investigation for PID regulator plane execution depends on tuning procedures by the reference and the straightforwardness case of execution and adaptability of proportional, integral, and derivative regulator have brought them into the synthetic interaction market. For first request framework to with time several modes of tuning approaches are proposed, and the work portrays the Sandreisen and Christamere approaching for inferring the FOPDD model, just a presentation correlation of PID regulator tuned with open circuit, short circuit, and inside motor control IMC system for set point following and unsetting influence demos. The next study paper we look at was speed control of DC motor using PID control based on artificial intelligence approaches by the reference show. And the goal of this study is to design a DC motor speed controller using a genetic algorithm and an adaptive neural fuzzy inference system to determine PID parameters. And this study analyzes three different parameter tuning approaches for PID controllers: the Ziegler and Nichols controller design, the genetic algorithm approach controller design, and the adaptive neural fuzzy inference system controller design are the first three. And the table 2.2 shows the effect of variation in rise time on various OP parameters of the PI, and PID controller. And these two tables show the impact of modifying control parameters and coefficient respectively. And as can be seen, the rising time, overshoot, and settling time have all decreased, and yet the steady state error has remained unchanged. Above is a list of all 11 research papers we completed before completing this project, and the goal of this study is to learn about the PID controller fundamental concept, theory, function, and application. The most important thing to remember is that the essential thought behind a PID controller is to examine a sensor at the point, calculate that desired actuator, yet yield by including proportional, integral, and derivative reaction. That's all from my literature review part. Thank you.
Good morning, my name is Susie. My material is AE190093. I'm from Group 7 Session 2. Today, I'm going to continue our presentation about problem elaboration. The issue is that this project calls for creating a block diagram for PID controller that may be used to regulate and monitor the speed of an electromechanical system. First of the electromechanical system block diagram is designed and developed in MATLAB Simulink in order to gain the fundamental knowledge necessary for designing such diagram. The input variable for this diagram is the applied voltage to the motor, and the output variable is the mechanical system shift speed. Next, a PID controller is implemented in the basic electromechanical system block diagram, where the input speed is set to 500 RPM and 1500 RPM respectively as to accept the output shift speed response. The output variable is mechanical component shift speeds as a result in the closed loop control system, where the PID is in forward rotate. Feedback control system frequently adds the input design information about apply speed to the input shift speed to produce new information that is long. The operation is so continue till the zero error is reached. Besides that, the Nickel method and automatic turning are used to manually adjust the KP, KI, and KT, and from the for the proportional PI, for the proportional P or proportional integral PI or PID and PID. In order to achieve the best shape speed response of the electromechanical system to be controlled, the block diagram of the electromechanical system is the open loop control system with the input speed variable set to 900 RPM to 1000 and 500 RPM or scale in the MATLAB simulating. In order to predict the output shape speed response, the error signal cannot be addressed because the open loop cross control system does not embody feedback to assess whether the output response has fulfilled the intent input instruction. In summary, the analysis is focused on minimize the maximum overshoot OS percentage 10%, rest time TR or settling time TS 5%, peak time TP, the error conditional stable ESS through mathematical calculation by using MATLAB calculation in order to compare manual and automated turning in MATLAB simulating to determine the gain of PID control. That's all for me. Thank you.
Assalamualaikum and hi, my name is Muhammad Nazmi bin Asmadi and I will explain about the 6.0, which is problem execution and result that we have gained from the MATLAB simulation. So these are the block diagram that we have to follow through in our MATLAB simulating. So this is the block diagram implementation in MATLAB software. It is just same like this. And then after that we have to set the value of parameter just like this, which is such as example for the voltage is 12 volt, the inertia of the rotor is 0.222 kilogram meter squared. And then in order to find the transfer function, we have to do the Laplace transform of armature circuit equation. Then we just derive the equation until we get the transfer function formula, which is 1.28 over VA. And then for C, we need to design a block of PID control that run from different speed, which is 500 RPM and 1500 RPM. And as you can see, this is the graph for the 500 RPM. And this is the graph for the 1500 RPM. It is the same graph, have the same shape. And then after we run the PID control with different speed, we need to determine the PID gain manually. So in order to get the PID manually, we need to determine the characteristic equation CE of the above block. And then as you can see, based on the transfer function equal to 0, and then we just this is VA, just apply VA equal to 0, and as you can see, S3 is 0.029524 and 1.6362 and so on. And then after that, we need to multiply it across. So A is equal to 4.4803 minus 0.03776k over 2.7332, and B we get the value is 1.28k. So in order to make the equation stable, firstly we need to derive it greater than 0. So the last one that we get is for the period of oscillation, we get it 0.84 second. So the next one is the table of PID gain through manual tuning. So as you can see, based on the P, PI and PID gain that we have manual tuning. As you can see, for P, the value of K is 59.326 and T is infinite. The rest one is 0 for PI. We get K 53.3934. TI we get 0.7. KI we get 76.2763, and the rest one is 0. So for the last one is PID. For the PID, for the PID gain through manual tuning, we get for K 71.1912, TI 0.42, KI 169.50029, TT we get 0.105, and the last one is KD 7.4751. So and then after that we need to, it can be said as like combine lah. We need to do the block diagram of manual tuning PID on MATLAB simulation. And as you can see, for the input speed of 900 and 1500 RPM, it is just like 500 and 1500. It have a same shape but different amplitude and so on. So as you can see, the max is different. The min same, peak to peak also different because it run on different speed, different RPM. So these are the automatic tuning system response for PID controller. For the controller parameter, we set the P 0.50955 for the tune and block, and the other rest is none. So as for the performance of the PID, this for closed loop stability, it is stable. Gain margin is same, phase margin is same, peak also same, overshoot same, the rest are also same. So this is the system response of PID. Start from 0 and again slowly. For this one, for the P, we set the tune and block 1.9969, D 1.7253, and N 15.3215, and you can see the rise time is 1.4 second for tune and block. The settling time is 5.15 second. So for the closed loop, it is stable. So these are the system response of the 1.9969, the parameter in the graph. So these are the comparison between manual and auto tuning of PID. So as you can see, for the manual KP 71.191, for the auto 1.5872, for the KT is 169.4029 for manual. For the auto is 0.2297. For the manual KD is 7.4751, but for the auto is 2.0365. So these are the difference that we have gained based on manual and auto tuning. These have the same parameter but different method of tuning. So I think that's all for the problem execution and results. Assalamualaikum and
Now with the conclusion, P, the fundamental term, generates a proportional corrective control action corresponding to the error. I, the integral term, generates a correction whose integral is proportionate to the error. This ensures that the tracking error will be zero if we apply adequate control effort. A control action is brought about by the derivative term D proportionally to the change in the error range. The type of system we are working with must first be identified, as the degree to which this is done will affect how narrow the tuning gains can be. Establishing the system's genuine stability right away is also essential. In each industrial application, a motor's accurate performance is a desired characteristic. Since a motor's performance declines with age, and as the years go by, it is vital to periodically assess it to ensure that the motor is running properly. It takes a considerable amount of time to calculate output performance indices the conventional way. A PID-based approach method performed effectively for the test system. The results show that the proposed PID technique takes much less time to solve problems than the conventional algorithm. So, a proportional controller KP will reduce the steady-state error and rising time but never totally eliminate it. The steady-state error will be decreased by an internal controller KI, but the sudden reaction might be made worse. Hence, the system stability will be raised, overshot will be decreased, and KD, a derivative controller, will also improve transient response. The normalized value of PID's output performance is extremely accurate in that case. I suppose that is all for us. For me, thank you very much for watching the video.